Hello my dear friends, welcome back. In the previous video, we discussed about the first topic of this chapter, eye and vision. So far, we have been trying to understand how different things in the nature are made visible. But what is the reason for these objects appearing different colors when sunlight falls on them? Will there be a change in the color of an object in accordance with the color and nature of light? So let's familiarize certain phenomena to know more about it. So the first one, dispersion of light. So let's learn more about dispersion of light. We are going to study dispersion through a small experiment. For that we need a prism, a white sheet and a cardboard. So place a cardboard at a position such that the sunlight falls directly on it. Next, keep the prism such that the light passing through the hole of the cardboard falls on the surface of the prism, and in the other end of the prism fix a white sheet as shown. As sunlight passes through the prism, you will observe a beautiful band of colors called spectrum appearing on the white sheet. If we look at the colors on the white sheet, they are in the order violet, indigo, blue, green, yellow, orange, red. This sequence of colors can be remembered by the acronym PIBGIOR. The light coming from the sun is white, and this white light consists of the 7 colors. When the white light coming from sunlight falls on the prism, it splits into its constituent colors. That means when the white light is incident on the prism, it enters into the prism and splits into its constituent colors. That means the white light consists of 7 colors from violet to red. And the red light bends least and the violet bends most. So the maximum bending is for violet and the minimum bending is for red light. Any light that is composed of more than one color is a composite light. So white light is an example for composite light. So let's see the definition of dispersion of light. The phenomenon of splitting of white light into its constituent colors through a prism is known as dispersion. Is it the sunlight alone that gets split up into component colors? Let's examine. So, here you can see a torch light and it is allowed to fall on a prism. And when the beam of light from the torch fall obliquely on the prism, they formed the 7 colors, that is PIBGIOR. Aren't these colors the same as the component colors obtained from the sunlight? Yes, it is same as that of the component colors obtained from the sunlight. So, in torchlight also, the phenomenon dispersion happens. So, this regular array of colors formed by dispersion is the visible spectrum. Among these spectrum of colors, can you say which color deviates most and which color deviates least? Yes, violet deviates most and red deviates least. What may be the reason behind this difference in deviation? The answer is the difference in their wavelength. Each color has different wavelength. So, this reason is behind the difference in deviation. So, let's compare their wavelengths by analyzing the table given. And from the table, we can see that the violet has the shortest wavelength and the red light has the longest wavelength. The wavelength of violet is from 400 to 440 and for red it is from 620 to 700. That is, when light passes through the prism, as the wavelength increases, the deviation of colors of light decreases. So let's see what is the reason for dispersion. Light undergoes refraction when it enters the prism obliquely and when it comes out of the prism. The extent of deviation depends on the wavelength. Therefore, waves undergo deviation at different angles and get separated. Next we are going to study about rainbow. All of you would have seen a rainbow. Yes, we can see rainbow just opposite to the sun after the rain. After the rain, so many water droplets are present in the atmosphere. Each water droplet acts like a small prism and refracts the incident sunlight. As soon as the sunlight enters into a water droplet, it splits into its 7 constituent colors, that is vibrio, within the drops. When this band of light strikes the other edge of the drop, it gets reflected internally towards the first edge of the drop. As the band reaches the first edge, it refracted again and finally comes out of the raindrop is what we see as rainbow. A rainbow always formed opposite to the sun. When the sunlight passes through a water droplet, it undergoes refraction 2 times and internal reflection 1 time. The appearance of rainbow in the sky is due to the dispersion of sunlight by the water droplets present in the atmosphere. So let's see once more, how does dispersion occur when light passes through the droplets of water. Sunlight, when it passes through water droplets, undergoes refraction for 2 times and internal reflection for 1 time. The light ray emerging from the water droplets, which make the same angle with the line of vision, have the same color. These droplets appear in the form of an arc of a particular color. Thus, there is red color at the upper edge and violet color at the lower edge. All the other colors are seen in between depending on their wavelengths. When the position of the sun is near the horizon, the rainbow appears to be bigger. When seen from an aeroplane, the rainbow is seen as a circle. When the sun is much above the horizon, the rainbow disappears. We can see the beautiful band of colors not only in rainbow, we can see this band of colors due to dispersion also in water fountains, soap bubbles and in CDs. So students, that's about the topic dispersion of light. I hope you all understood the topic, learned well. Thank you for watching. See you in the next video.